Now you can start asking the questions that you have related to this module, and I will try to explain. Any question, any concept that you want to understand related to chapter number 6 and chapter number 7? We are skipping chapter number 5 because chapter 5 will be covered in next course, which is BADM 520. So any question you can start asking, because this module is little challenging. It is totally based on probability, different probability distribution. And chapter 6 is about discrete probability distribution. And chapter 7 is based on continuous probability distribution. So it is important, by this time you have gone through the reading and other things. So if you have any question, you can ask me.
I had a question on using Minitab in this module. So I'm on the on a Mac, so I've got the online version, which looks a little different from the video that I've seen that you use on the model. So when you go to Minitab and select calculate, when I select probability distribution, before I can enter anything else, it gives me three options. It gives me cumulative distribution, inverse cumulative distribution, and probability density function. And sometimes it's confusing for me a little bit as to which one to select.
Okay.
When I'm trying to calculate those.
Okay, that's good question. Thank you for asking. Let me show you right on the Minitab Cloud. I opened both, I opened the Windows version because I use on Windows. It's a very fast and all. And I have also cloud options. So I'm just going to demonstrate you both options. So here, can you see my screen?
Yes.
Okay. And any other question related to this? So, okay, right here we have a Minitab. Actually, Minitab has very good visualization of distribution, probability distribution. And what I do, I go under graph. So there are, calculate, you have probability distribution under graph. So first thing first, when you choose, when you try to do the questions and try to solve the problems, first step in these chapters to identify which distribution is this. What is the type of distribution? So here I go under probability distribution. So this is a online or cloud version I'm demonstrating you. Here we have all, different options. So view probability. So I just want to see the view probability, little bit different. Now we have all the distribution that we need for our purpose. Let's say binomial distribution, which is first distribution that I have a question related to that. So binomial distribution. Now binomial distribution, number of trials, which is n, let's say n is 12, probability event probability is 20%, which is 0.2. Now we have an option. You need right tail, you need left tail, you need equals, middle. What you need? You need X value, or you need, what? So let's say X value till 2, or, you need up to 2. So left tail and 2, and then I can put it in this, and you can get the answer right here. So can you see 55.83, whatever is the number right here? You can see this is the probability. Now, when I do the same thing, this is my Minitab. If you can see my Windows version, here I go under graph, I go under probability distribution, I go. So little bit, little bit appearance is different. Number of trials are 12, event probability is 0.2. And this area, let's say I put here X value is 2, as I did on cloud. And oh, sorry, I selected the wrong distribution. So I have to do right, we selected the left tail. So this is the option, this is the option. And here I have to select this option, which I selected. And you can see exactly the same answer is coming in both cases. So this is Windows version, and let me show you, this is cloud version. There's no difference except little appearance or aesthetics or little changes are there. So this is one thing. Calculate, like same thing I'm going to calculate, like you ask Marais. Oh, sorry, Theo.
Yes,
So
yes,
here,
sorry.
yeah, look into this, calculate probability distribution. This is online I'm showing you. And there are three distribution: cumulative, inverse, and probability distribution. So we are looking the cumulative as of now. So I just go under this. So first I need to select the binomial distribution. Number of trials are 12, and the value we are not, and event probability is 0.2. So a single value, and we are going to do 2. Is it coming? No. So just a minute. I mean, first time I'm using this part here, online version, but let me cumulative distrib function. So first I would like to explain you value 2, single value, which is X value, binomial, event probability. Okay, let me see. Okay, here you go. I mean, this is the option, which is the same number. If you look into this 55.8 that we got, here using this, we can see, we can visualize. Here we can see, this. Now the same thing I'm going to explain right here in calculate probability distribution. This is my Windows version. And here I have binomial and cumulative number of trials 12, event probability 0.2, and input column I'm using, and here we go. And you can see exactly the same value. So basically, we have the options to choose. If you understand the concept, it doesn't matter what option you are choosing and how you are choosing. Even you don't need to do this. When I used to do my calculation under my master's, and when I was pursuing my master's, I didn't have calculator or a computer. We have tables. So I can show you the same value using tables. Give me a minute. So I think I have somewhere the binomial distribution. So binomial distribution. So table. I'm just pulling the table from somewhere, and I can show you. Okay, right here. Or you can look into your book also. Can you see the screen, my screen?
Yes.
Okay, now go here. So what is the n? We selected n equal to 12. What is the value of n? And pi is point, or probability is 2. So point probability is this 2, n is this, and these are the x values. So first we need to go for n equal to 12. Okay, look into, we are into 1, 2, 3, 4, 5th column. Okay, so n equal to 12. Okay, can you see this? This is n equal to 12. Now we are going to see 5th column, which is, this is 20%. So this is 20%. Now look into this. So what you are going to do? Look, so we are going to see up to 12. So this is the one up to 2. Sorry. Now sum all these plus, plus, plus. Are you going to get 0.5? So I'm just going to demonstrate. Just a minute, and calculator. So can you see my calculator here? The simple calculator. Okay, look into 0.069 plus 0.206 plus 0.283. And you get the exact same value 0.558 that we got on where? Where's mini tab that I used? I think it. Okay, here you see that this is this is 0.558. Exact same value you can get through using table also, because tables used to be old fashioned. Now we have all sophisticated calculators. I have also Texas instrument that I can demonstrate, but demonstrating so many things is not important. Important is understanding the concept. Yeah, you can see the, yeah, so basically I'm going to explain why we are going to do. Okay, so basically before going, why we need to add, Bridget, you are asking, okay, this is a very important concept. Why do we need to add and why don't we? So here I'm just showing. So Theo, am I able to answer your question? I can't hear you.
Sorry, yeah, I was on mute. Yes, that helped. I've got one more question after you go through Bridget's question.
Okay. Okay. Now here we have, okay. Why we are adding, you must understand this concept. Then, let me remove this clear. Okay, understand. I mean, I normally explain through salary, which is very simple and everyone can understand. Can you see my Excel part? Can you see?
Yes, I can see.
Okay, go ahead. So here, this is month, this is salary. Let's say, your salary is variable. It means it is not fixed. It has some fixed part in your salary, plus it has some variable part, which is like based on your performance, based on your sales or something, you will get paid over 12 months. So basically, this is January salary, February, March up to December. So if you can see these numbers, and if I add all these numbers, so this is, and when you get, paid every month, you get the, so far in your, let's say you are getting paid in March. So you will see cumulative, or so far you got paid 30,600. Or, at the end of the day, when you get W2, you get, that $121,700 is your total payment. So basically this is a cumulative. So January now, okay. So basically this is, if simply or very easily I explain, this is your salary distribution over 12 months during a year, particular year over 12 months. So this is, you can say, salary distribution, isn't it? Now, if I plot a graph, just a minute, let me. So can you see the chart? So this is your salary distribution chart. Now, if I ask, what is your salary in the month of May? And you can clearly see, you can clearly answer $11,000 is your salary in month. If I ask, what is your salary in August? You will say 10,500. So basically, this is very easy to explain. Now, if I ask question, what is your salary before May? What is your total salary before May? How will you answer? You
January,
have to,
February, March, April.
Yeah,
Correct.
you have to add all of them. But this is 4-step process. Or, if I ask, what is your salary after May? After May, so basically, if you want to know
after May, sorry, pardon. Yes, correct.
So you have to add this means June, July, August. It's a little complicated. Therefore, it is easy. So I'm just going to, get rid of this. This I did cumulative that we get here. So let's see, I'm just going to draw Oh, sorry. I'm going to plot cumulative distribution. So insert and okay. So this is a cumulative. Let me put the labels. And now I have, now what is your salary before May? What is your salary before May?
40,100.
Exactly. You just don't need to do anything. You just look into this cumulative and you get the answer. What is your salary after May?
We take that 40,000 and minus it by 121,700.
So basically 121,700
Mhm.
after May. You know, I'm not asking May, and then you subtract till May, which is 51,100. So 121,700 minus 51,000, and whatever answer you get, that is after May. What is your salary between May and July? Or, you know, okay, let it be, don't make complex. So basically how cumulative works, cumulative is, you know, when you make a cumulative distribution, it adds previous. It's very easy to tell the value after, before, isn't it? Why we do this? You know, similarly, the total probability is 1. Total probability is 1. 1 means 100%. So suppose somebody asking what is the probability of before 2 or, you know, after 2. After 2 means, you know, this value, then subtract up to 2. Then you get the value of. Is it making sense to everyone?
Yes. Well, to me anyway.
Yeah, I mean, I'm asking to all students in the class, please say yes or no, or you don't understand, or repeat it. Okay.
Yeah, makes sense.
So this is a purpose of cumulative. So similarly, okay, here we have a graph. Okay, so here we have a probability distribution. Okay, let me go one more thing, then I will go over here. Where is my distribution? Okay, can you see this? If you see this, this is a binomial distribution. And you can see n equal to 2, 3, 4, 5, 6, up to 16 or up to 20, you can see. So if you have n equal to 20, you can use binomial, means sample size should be up to 20, then you can use the binomial. After that, you know, binomial approximation comes, which is in chapter 7. I will explain that also. So basically here, you know, these are the probability distribution, probability of any event, sample size, and you are looking, this is X value. Here they have demonstrated as a R, but you know, these are the X value. So basically a practice. So what should I do? You know, tell me what I should do if you are not able to, you know, this is exactly done. If you know, if you can't do it, you know, this is the option for Minitab for this. Table is option. Fourth is option is Excel. You can do the same thing in Excel. Book demonstrated very well how you can get all these values in Excel also, which I'm not covering here. So it's all, you know, you have all the resources. I'm one of the resources in online education or online this subject. You have all the resources at your end. Whichever you want to use it, because you know, these are the universal methods, universal technique, it doesn't matter. You are using Minitab, you are using calculator, you are using table, you are using Excel, all are same. So, basically it comes with the understanding of the concept. If this is just simple calculator. It's simple calculator, as I think I have here Texas Instrument, also TI, if I can say TI Smart View, if I can open here and show you. So this is another calculator, which is Texas Instrument. And if I go here and you can see, can you see my Texas Instrument calculator?
Yes.
Okay. So here I have, let me show you where I can see the distributions. So second and stat. Just a minute. I teach to undergraduate using this.
That dates me too, because I used a real one.
Yeah.
When I was in high school.
Yeah. So yeah, that's what, I used to teach, I'm just because from last 3-4 years, I'm not teaching any undergraduate. So I forgot how to use, but all the options are in this also, which means you can do the same probability distribution here. And I have to see this maths stat. I have to see second and stats, I think. Okay, let me see stat. Okay. And calculate and test. Here we have all one sample, Z test, T test, distributions. Okay, here we go here second, and we have, you can see the second and distributions here. Now you can see the distributions, all the distribution. Normal PDF means probability distribution, CDF means cumulative distribution, and you can, keep going here. T distribution, chi-square, binomial PDF and binomial CDF. Here you can see the binomial. Same thing I'm going to here. Number of trials are 12. Probability we have 0.2. X value we put 2 and look into that. So I think something I made a wrong thing. So let me clear everything and then do it again. Because clear, and I think I need to clear this so I can see TI. Now I go under second and I go under distribution, and now I have binomial. That is what we are doing. Binomial CDF. Number of trials P equal to 0.2. X value is 2. I think it should come. 12.2 and 2. So here, this is coming answer point, I think. Yeah, 0.5583. This is the answer we are getting here. Something, because it gives direct one sort of thing. I have to see because something is changed, and so this is the answer. Let me see one more thing. So clear everything. It is recording all the things at the back. Clear. Now second and distribution, and let me go again on binomial PDF. Let me do it. Trial is 12. Probability is 0.2. X value, let's say 2. And so this is giving 0.28 value. Let me check with my, so 12 here, 12, this is 0.2, I believe. Yeah, 0.2. So X equal to 0.283. And what we are getting here, 0.283. So basically the answer is coming what we are. So same thing we were doing here, distribution, second, and then distribution and going, and we can get 5583. So little bit changes are there in the 12. You do this, P is 0.2, which we were doing, X equal to 12. X equal to 2. And so this is 0.5583, we are getting the answer. This is a probability that we are getting. But Excel also gives same thing. Let me try on Excel also, because you have the complete instruction on Excel. Here we have formulas, and if you can see the Excel formula, and we have to go under statistics or to some more function. We have statistics and look into the binomial distribution. Binomial distribution. So this is binomial distribution. Here number of trials are 12. Probability is 0.2. S is 2. So this is giving only for 2 only, because this is, which is 0.28. So 0.28, which we got here, 0.28. So this is not giving, but you have to do for 3 steps in order to do the cumulative. Let me do one more time. So you have all the options. It's only practice. Statistics, binomial distribution, and let me see. Number of trials are 12. Numbers 12. Probability is 0.2. Cumulative, and 2, I think. I will get the statistics binomial distribution 12. Okay, hopefully we will get. So you have to enter in particular order that I'm missing something, but you have exactly the same way of doing. Trials is 12, probability is 0.2, cumulative is 2. Hopefully. Yeah, something, I have, you can see on the book. True for communication, true, false for communication. I have to see here, true, false for cumulative. So basically, Excel can also do the work for you. Calculator can also do the work for you. Tables can do, Minitab. So Minitab is just a calculator. Okay, one for CDF. Thank you, Kathy. Thank you for telling me. Yeah, I have to see, yeah, for 0 for PDF and 1 for CDF. Thank you. So it can be done. Most important is concept. Any other question that I missed in chat? Okay. Okay, I think I answered all the questions. Any other question, please let me know.
Hey, Raj,
Yeah.
can I ask you a question about a couple of the previous quiz questions, or do you want to wait till we just keep on chapter 6 and 7 till the end?
Chapter 6 and 7. Yeah, I can. For previous week you are asking about. Okay.
Yeah. Yes,
Go
sir.
ahead. Go ahead.
For that question about, I was talking about the quartiles, and I get the concept, and I couldn't get and I got the numbers wrong for whatever reason.
Okay.
And I don't understand. If you could, I'll bring up this question. Well, shoot,
Okay.
it was the question that I emailed you about. It was the number like 5 and 6. I could
Okay.
send it to you if you want, but
Okay, no problem. Let me go with just a minute. So let me pull the data. It is related to Titanic data.
yes, correct.
Okay.
I believe so.
Okay, here is the Titanic data that you can see. Okay, it is coming. Wait a minute. Okay, this is the Titanic data. And the question I have asked, related to here, you go under statistics, statistics, basic statistics. And here you have the descriptive statistics. Okay, here we go. And and we need to do 4, 5, let me remove all, none. Now I select median, first quartile, third quartile, median. So basically first 2, 3 interquartile range. We need to select minimum and maximum. Okay, here we go. All the answers are within this. How?
Yeah, so when I did it, it only gave me quartile 1 and quartile 3, and I was trying to do the intermediate range. So it asked, the question was, give me the first 50%. So I
First
didn't have
50%, basically, first 50%, if you look into, think. So 0.7, I can draw the graph here, right here. So 0.72, what is the highest? 74. And what is 30 is the middle point. And 23 is this point, Q1, Q2, and what is the third point is 38, Q3. Now look into the, so basically if I ask first 50%, so this is first 50%, this range. So 30 minus this, basically it is about 30 is the right answer. First 50% is this.
Okay. So 17 minus 30?
No, not 70. It's a 0.17.
Okay, 0.17.
Yeah.
So you take 0.17 minus 30, and that
No,
gives you
30 minus 0.17.
Oh, got it. Okay, I don't know what I was doing, but okay, that makes sense. And then obviously the first 50% is 30 minus 74, which is
first 25% is 23 minus this.
Right.
Top 25% is 74 minus 38.
Right.
So basically, it's a different kind of permutation and combination. I think those I ask in the, there's one more question that was asked by someone, not able to do the infant one. So let me show you. Here is, okay, here we have a graph. And I plot the histogram. Do you want me to do in cloud version or this? So here you go with simple. So here I plot age. Sorry. Okay, right here. Okay, I'm just doing it. Now I go and do the right click and edit graph here. Under this, I select the bins. So binning. So you can do the midpoint, cut point. You can select, all number of bins. So let me select the number of intervals. Let me do 12. Okay. So now the histogram has been changed. Now I have a very, particular range that I need to define. So here I define, I select the cut point. I choose the cut point. First is 0, or let me first to 1.99. I think infant.
I think it was 2. I think it was like 2 and anyway, whatever.
Oh, okay. So 2,
Yeah.
I think infant is up to 2 or
Yeah.
okay. If somebody becomes 2 years one day, then not considered infant, isn't it? Okay.
It was some, I think that was the question, but I
Yeah.
could be wrong.
Yeah,
I think
because
you're right.
airlines, they don't allow, if your kid is more than 2 years, then you have to pay for ticket. So I consider that is a definition. 20, 30, 40, 60, I'm just giving 80. Okay, these are the cut points. And let me do one more thing and add labels. Okay, here we go.
Oh, there it is. Okay. Add labels. I couldn't figure that out. Thank you for doing that.
Yeah, so basically you can see, up to 2, how many kids were there. So
21.
very simple. I mean,
Got it.
if you are doing any business problem, you want to see the customer in that particular spending range or whatever, so you can do the range. Okay, you can see that percentage of customer are within this income group or this spending group or this kind of age group or whatever. So this this is the easy way to do and find the answer.
Yeah, that explains it to me. Thank you.
You're welcome. So any other question, please?
I've
Yeah, go one by one, please.
Yeah, for me, yeah, I couldn't find the cut point in cloud version.
Okay.
So I had to do it in Excel to get the answer.
Yeah, in Excel also, if you sort this, age.
Yeah, I had to sort it.
And then you
Right.
count, you can see, okay, this is coming up to this 21 or, 21. Even here I can do, for example, I'm just trying to see data, and I can sort and I can select the age here and increasing. Okay, let me do this. So here I have sorted this age column, and let's see up to 2 where I'm getting up to 2. Where is 2? No. So sorted age, why this is something is mixed. Something is wrong. I am not able to. So what is the answer that you are getting in terms of sorting? 1, 2, 3, 4, because it is coming more than 22. It is coming how many? 34.
Yeah, but since it's less than 2, you can only count ones and zeros for the age up to 1, all the ones and all the under ones.
So basically, this is up to 2, because there is a cut point. So here we are getting up to age 1 is 21 and 2, and over 2 we are getting this. So this 21. So cut point is 2 years we put in our this. So here we go under edit part and edit. So winning, and we put a cut point. Cut point is 2, means up to 2, before 2 or just 2. And let's say 10, 15, 20, 40, 60, 80. And let's do it. And it was data levels, add data levels. Okay. So I have done something here. This is coming, whatever minor is coming up to 2. The second stage is considering 2 plus or whatever. So up to 2 is coming 21, which is just below 1. So just a minute. Here we have the, so here we have 21 right here, and this is also coming manually. This is also coming because they are no. Yeah, so we don't, I think infant, 2 years, when somebody turns 2 years, that is not considered as infant. Less than 2 years is considered infant, if I'm correct. Because airlines don't allow somebody, let's say today is the second birthday of the kid, then I think probably somebody has to pay the ticket. Anyone has any clear answer about this? Yeah, because I checked, for my daughter, and when, I said 2 years, then it was charging a full price. Okay, yeah, problems. So if this is, 21 is coming in both cases. Any other question that you have, please let me know.
I just have Thunder, I've got a comment for you on the online version.
Uh-huh.
You could get the cut points. I found it if you went to, you created your histogram and then you say graph options.
Mhm.
South Africa.
And under there, you'd have to go to scales. There was a something called scales, and in that drop down, you could set your cut points. It was a little bit of digging, but you
Yeah.
Okay, so
possible to get there.
I mean, I think, let me see if I have the data here. I can do, or let me copy some data and show you how we can do in. So basically, you can import this data also in online versions. So let me edit file, open project, local file. Okay, and let me find the Titanic. What do I get? Let me use the data which I have here. Okay, so this is, for example, oh, I did wrong. Okay, this is, let's say, let me make the graph of histogram and simple. Okay, let me do for ZRE because it has select option. Okay, and so this is the, do we have here the option?
Graph options.
Graph option.
Yeah.
Graph option right here, and you can see the scales.
Scales, yeah.
Yeah,
And
you can do the cut point,
Yeah,
number
that's
of
where you find
intervals, number of intervals, like 10 cut point. You can decide. You can do all sorts of things in cloud version also.
Mhm.
The look is little different than the actual Windows version.
Mhm.
But
Thank you.
all the options are there. Can you show that the full window version? So this is a window version that is right here with me.
Right. Can you show what you just did in the because you were in the cloud version?
Okay. Means I just showed how you can do the cut point and
oh, you did. Okay, it's the same thing. Sorry.
Yeah.
I thought I missed something. So
no. Any other question, please? Go ahead, one by one.
Can you also go over the last quiz? The one that you said you were going to go over about the weight and height or something. I forgot the the question.
Okay. Okay. So that the I don't remember. The question is the girl Freda
The
question?
Frida, yeah, the weight.
Yeah, okay. Just a minute. Wait a minute, let me pull the question, then I can show you. So there were 3 or 4 options, which is the best option that you can select or you can choose. So I think one answer is related to that. Just a minute. Okay. 1 minute, I'm pulling that so you can. One minute, I'm pulling the question. So module 3, module 2, and it is chapter 3 or 4? I think chapter 4 quiz.
It could be, yeah. It's a Frida is, I think 67 inches tall or something and 135 pounds.
Which question you, it's a
I
chapter.
think question number 10.
Okay, just a minute.
I think it's chapter 4, yeah.
Okay, question 10. Yeah. Just a minute. So, I mean, very simple answer if you remember the Z value. And so let me show you, this is the question. Oh, this is the answer. Z equal to X minus mu divided by sigma. If you know, this is a, so Frida height is 67. If I have to read the, Frida is 67 inches tall and weight is 135 pound. Woman, her age is mean weight is 65. Height is 65 inches, standard deviation 2.5. And mean weight is 125 pound with a standard deviation of 10 pound. So this is what is very simple. So say you can look into X equal to 67. This is her, and divided by 2.5. This is a standard deviation. Now similarly, you look for her 135 minus 125 divided by 10. So this value is coming how much? 0.8. This value is coming about is 1. Now look into the normal distribution. This is normal distribution. So, you know, this is a mean. So whatever close to mean is, you know, okay. So this is her on normal distribution. This is her weight. And this is her height. So this is 0.8. And this is 1. So the Frida height is more unusual than her weight. Is it making sense? Because, you know, so use, you know, mean, or this is a mean. That means if somebody is close to average, okay, that's so weight is close to this. So weight, so Frida height is unusual than weight. Is it making sense? Is it making sense?
Yeah, now I see it. Yeah.
So basically, this, if you look into the normal distribution, if anything is close to mean, okay, you can say that is mean means it's a normal or, average of all. But if you go, let's say your weight is close to this, but height is in this top 5% or whatever, then you can say your height is unusual than weight. Height and weight proportion must be about same.
Okay. Got it.
Any other question? Please feel free to ask. If no, then, I have few important things that I would like to share related to this chapter 6 and 7. What is the difference between discrete probability distribution and continuous probability distribution? So I'm sharing the slide part, and please follow the slides because all the important concepts are right here. So here we go. Can you see the slides part? Okay.
Yes.
Yes.
So basically, like, uniform distribution, I have not given any question or any assignment or in final, but what is uniform distribution? Let's say in my class, or in undergraduate class, there are 25% students from junior, 25% students from senior, 25 from sophomore, from freshman, 25. So equal distribution means everything is coming equally. So uniform distribution means distribution throughout is same. So now binomial distribution, when do we use? So these are the few points that you need to keep in your mind. Question is related to which distribution. Binomial, when you have only two options, yes, no, success, fail, happening, not happening. Let's say today I will go to my car repair, for my car repair, 20% probability that I will go for car repair, then 80% probability that I will not go for car repair. 40% chance that it may rain, then 60% chance it may not rain. So basically you can say success, failure, yes, no. And this chapter is about discrete distribution. So means only 0, 1, 2, 3, 4. These are the discrete probability events. And you have to understand those things. Means only discrete. It will not ask in between or anything. So basically 0, 1, 2, 3, 4. These are the discrete events. You know what is discrete? Let's say if I ask, there can be in my class 9.5 students are there. In the parking lot, 20.8 cars are there. No, it is not possible. Either there are 9 students in my class or 10 students are class, there cannot be 9.5. Similarly, there cannot be 20.8 cars, only 20 or 21. Even, the car is broken or something, it will count 1. So discrete means these. Yeah, correct. That's correct. Continuous can be anything. My weight is like 180 pound, 80.4 pound. Okay, this can be possible. My the car speed is this much, 140 point some miles per. So whatever can be in in continuous scale, that is in chapter 7. So probability so now I already explained what is CDF, what is PDF. Now think about binomial distribution. So I'm directly going on binomial. Binomial means success or failure, yes or no, happening, not happening. So if success probability is, let's say, 20%, then failure probability 80%. So opposite, but total probability should be only 1. So probability of 0, probability of 1, and pi can be, or probability can be between 0 to 1. Any value can be possible. Now the sum of all the event probability is 1. So whenever you see this kind of situation where pi or probability is given, then you can go for pi. What are the 3 numbers you need to understand in this? First is number of trials, means sample size, probability of success, and what is the X value you are looking. Before looking into that, you have to also understand whether you are going to do cumulative or it is asking only July month salary, or it is asking up to July salary. So basically you need to distinguish between PDF and CDF. Now n pi, mean is n pi, and standard deviation is n pi 1 minus pi. So this is how it is done. So if you know three numbers, you can find the answer. Now we come to the cumulative. Very important slide is this 26 number, because you can see in questions, you will see whether at least 2, it is asking at least 2, means including 2. Fewer than 2 means it doesn't count 2, less than 2. So basically you need to understand in cumulative, binomial and Poisson distribution, what is the actual X value needed to insert in Minitab or that. So basically this is binomial distribution. Poisson distribution, whenever you have something in average, if anything is given you in average, let's say in your store 20, on average 20 customers visit per hour, okay, that itself is a Poisson distribution. On Seattle airport, every hour 20 flights land, average 20 flights land, okay, that is Poisson distribution. So look into this Poisson, and that is denoted by lambda. So think about whenever such situation comes, that is Poisson distribution. Here we go, and that is represented by lambda. So lambda is mean, square root of lambda is standard deviation. Why we are talking about mean and standard deviation? Because these will be used when you convert these distribution into normal distribution. So similarly, Poisson distribution you can do, and here is my, so let's say I go under graph, I go under probability distribution, I check here and I do the Poisson distribution. I have to only give average 1.7, let's say, and what I'm looking is, above value or lower value, you need to check whether it's a left tail, right tail, and I put, X value is up to 2. And you can see this is the value 75, 72. This is the value. This is the probability. You can also compare the same value in table. So in table, the 0 value is 18%. 1 value is 31%. 2 value is 26%. Total is 72%, 0.7572. So you can see the table also. Poisson distribution, similarly cumulative in Poisson distribution. Now we come to the hypergeometric distribution. This distribution has finite population. Finite population, let's say the Eastern Washington has 1,000 students, MBA students. So that is a population of MBA students in Eastern Washington. And let's say I take the sample of 200 students from, so it is finite population is 1,000. I'm taking 200 sample and then doing. So hypergeometric distribution is exactly like a binomial, but here we have finite population. So here now a very important few questions you will notice in assignment and homework. Look into that. Similar to binomial, but sampling is without replacement from finite population. It can be approximated by a binomial with pi equal to s upon n if n upon n is less than 5% and is symmetric. So look into that when you can compare this distribution with binomial distribution. You can change this, that how you can convert this pi s upon n. The value of pi will be this. If n upon n means sample divided by population is less than 5%, then you can consider this. So, always look into the case where this situation occurs, then you can blindly go into the binomial distribution. So this is hypergeometric case. Everything is recorded and you can see I already explained all these things over there. Then we have so this is a rule of thumb. Please note that if n upon n is less than 5, it is safe to use binomial approximation to hypergeometric. Means you can, instead of hypergeometric, you can use binomial using sample size n and success pi would be s upon capital N. So few questions you can clearly see related to that. Geometric distribution is another thing. And here X is the number of tries until first success is occurred. So let's say you are doing any donation event, when the first donation will come, 10th person will donate. So here, at university, 15% of an alumni make a donation or pledge during the annual telefund. What is the probability that first donation will come on 7th person or 7th call? So their event probability is this, but what is the probability that 7th will give, or so when the first success will be occurred. So this geometric distribution is applied in that case. So basically this is about chapter number 6. Now let me briefly go on chapter number 7. So now very important thing, in previous chapter, event probability on particular event or particular X value can be possible or can be there. But here in continuous probability, look into this and see, this is the most important point to to differentiate these two chapters. Unlike discrete distribution, the probability at any single point in continuous probability distribution is 0. Please note that always. So what we look in this chapter, we look the area between 2 points. So here between A and B, what is the probability? That is what we look into this. let's say I'm just giving, and what are the two important item you need? Mean and standard deviation. Okay, mean and standard deviation. So I'm going to show you here, and Gavin is asking the question. Okay, I will let you know. So look into this. Let's say you give the you give some GMAT exam, and let me put the normal distribution. Where is normal? Here we go. What we need, average GMAT score of all the student is like 625. This is average with a standard deviation 20. Okay. Now I want to know if my score is 725, in what percentile I am in. So I just put here X value and I can do the 725. Okay. And now I can easily understand, which is, it is saying 100 percentile. So let me get some small numbers, probability distribution. Let's say instead of 7 or 650, I'm just saying instead of this, let's say I'm going to see, I have to do the left tail, or I can say in top 10 percentile I'm in. So basically this is about 90 percentile. Average is 625, standard deviation 20. If I score 650, then I'm in about top 10 percentile. So I can do this same thing, and I can do this instead of this, and then I can see it is about 89.44 percentile. So if you know two numbers, mean and standard deviation, then you can do, you can see. Now I need to know where's the 95 percentile cutoff of this 625 and this. So how I can do probability distribution, here we go. And I put 95 percentile. So I put here the, this 95 here instead of X value. And I can see there. So somebody who scored 657 or 58, 658, they are about 95 percentile. So this is a normal distribution. Standard normal distribution. Standard normal distribution, for a standard normal distribution, mean is always 0 and standard deviation is always 1. I explained in the last class. So I'm going to answer Gavin your question.
Thank you.
After this. So
Sure.
now chapter 7. So we are interested to know here the area between 2 points. So basically, again here uniform distribution and everything, we go directly normal distribution, standard normal distribution. This is z value equal to x minus mu upon sigma. I demonstrated in the last class how we can do this. And there's an option in Minitab to make your data standardized data. So let's say here I can do the data standardized. This is a standardized. So if I want to convert the age into this standardized format, I can do this standardized, and automatically age store result in which column? C9. And this is, so this is how it is converted. This, whatever is the mean of entire age, mean, standard deviation, and then individual value subtracted and divided by this. So you get this. And now I can see the average of all this is about 0 and the standard deviation is 1. So I can show you clearly histogram, and you can clearly see, and C9, and here you can see in the, so mean is almost 0 and standard deviation is 1. So this is a standard normal distribution. And so basically tables are given. It asks the area between two value. I already demonstrated 2 sigma, 4 sigma, 6 sigma. So a standard normal distribution. Then inverse value of that same. If you know pi value, then you can p value, then you can do the you can find the x value like I did for I wanted to know 95%. What is the x value or what is the cutoff of that? So inverse normal. Now, very important. I think somebody asked this question. How we can convert binomial distribution into normal distribution? And this is a most important concept. N pi must be greater than 10. And 1 minus pi must be greater than or equal to 2. If these two conditions fulfill, then you can convert binomial distribution into normal distribution. Then what is the mean value? Because for normal distribution, we need a mean and a standard deviation. So before converting, you need to make a mean value for normal distribution. You need to convert it to this and I think fill in the blank of chapter 7, MCQ chapter 7, question number 4 is about this. So it is clearly given binomial distribution. You convert mu, this, and then you do. So this is binomial distribution. Similarly, you can do normal approximation for Poisson distribution. Poisson. In this case, when lambda is large enough, average is large enough, if you look into the table of Poisson distribution, the value of lambda is up to 20. If I so this is binomial. Now let me show you if there is a Poisson distribution. This is normal distribution. It is up to, I think, 16 or 20. If n equal or lambda equal to 20 or more than 20, then you can convert Poisson distribution to normal distribution. And here we go. Sorry. So here lambda equal to 42, which is large enough, then you can use the normal approximation. How? Because for normal approximation, normal you need mu, and the standard deviation lambda is mean, which is same. A standard deviation is square root of lambda, that becomes a standard deviation. So you need to convert in these things. Now, exponential distribution is another thing that, so if event per unit time follow Poisson distribution, the time until the next event follows the exponential distribution. And this is another another thing. And this is left tail, this is right tail. And so for example, here what you need to do, you need to convert all the unit in the same situation. Let's say I think I'm going to solve one question that is given in fill in the blanks. Okay, fill in the blanks. So I'm just solving one question that is related to earthquake. So let's say here, so here, we need to put 1 by lambda is the value that we need to put, whereas mean is 1 by lambda. Can you see this? Mean is 1 by lambda. So we need to, so the question says, that 3 times, or I think three earthquake in 10 years. So, and what is the probability next 6 months? What is the probability that earthquake may happen? So 3 earthquake, I think, so if I'm correct, 3 divided by 120 months. How many months in 10 years? 120 months. Okay. So what we got here? This is the number that we got, but this is, we need to put 1 by lambda, 1 by lambda, So we have converted into monthly basis. So here 120 month, which is this. Now we have to convert 1 by lambda. So 1 divided by 0.025, which is coming about 40. So we got this value 40. Now, what is the probability in next 6 months that an earthquake may happen? So I go and I solve this problem and I go under graph. So here probability distribution, if you can see. So basically I'm just answering. So here we have exponential. And here we have 40. Okay. Now 6 months, we convert into 6 here. And now look into, here we have the probability is 13% that, in next 6 months, based on last 10 years, three earthquake happen. The probability in next 6 months, 13 or 14% chances that earthquake may happen. Is it making sense? So now I answer the question of Gavin. Yeah, one more thing. Sorry. So this is about exponential. There is also triangular distribution. So basically this is exactly the same way. You have to convert both unit into the same way. So exponential triangular distribution. So basically the shape of triangular distribution is like this. You have a start point A, you have peak point, and you have the last point. So A, B, C. So one question or two question is based on this, and it is asking the standard deviation, in the fill in the blanks, it is asking standard deviation of, it is given A, B, and C. So use this formula manually to do that question, this formula. And then one is also probability. You just need to put, 3 numbers and you can see the probability like here. So I show you here graph probability distribution, and here I go and I show you the triangular. So beginning point, let's say 10, middle point is 30, and last point is 60, or let's say 40. Now I can find the probability or X value, or 35, let's say. So you can see this is the probability, which is about 90%, 91%. So this is a triangular distribution. One or two questions are also there. So any question related to concepts of this chapter 5 and 6, 6 and 7, please let me know, then I can answer the Gavin question. So Gavin, I'm going to answer your question now, and I'm using whiteboard to explain you. Okay, clear order. So you have asked, 40 but less than 50. So 45, okay. 50 and less than 55, 65, 75, 80, sorry. Can you see my whiteboard, Kevin?
Yes, I can.
And now how many are there? Frequency 6, 18, 65, 14, 9, sorry, please bear with hand because I'm using mouse. So
yes, no, I totally get it.
So whatever number is there, whatever number is there, whatever number is there, whatever number is there, sum all, whatever value you are getting, sum all.
Okay.
And then divide by how many frequencies are there? 50. And then you will get.
Got it. Where was that answer described? Because I was having trouble finding it.
So basically this is, based on the previous knowledge. When you study the chapter, you will get to know, if you study the chapter properly. And I think we studied this in our schooling time, and that this concept is very basic concept.
Okay.
If you have any range, you take the middle point, you multiply that.
Okay.
So sum divided by 50 and you will get the answer.
Got it. Yeah, I could find it, but thank you for doing that. Appreciate it.
Most welcome. Any other question you have, please ask, because this is really, little difficult chapter as compared to in both the courses. Means this course and next course you will do. This is the easier, this is the most difficult. Rest of the life in both the courses are, normal now after this module. And, most important thing, how to study these two chapters. My first suggestion to everyone, please make, points that, okay, these are the 2 points related to binomial, 2 points related to Poisson, related to exponential, hypergeometric, geometric, first thing to distinguish, first step to distinguish which distribution is question is all about. The second question is whether it is asking PDF and or CDF. The third, can we do some approximation, means any condition is fulfilling, and then you can just, it is asking lower, it is asking above, and then just use the, so basically the last step comes Minitab or Excel or any calculator or table to get the answer. But before that, these 4 steps totally based on your understanding. So this question, I mean, you can ask, because if I can explain all the questions here related to fill in the blank, then it will not make sense. So Mohammed, you just try. Yeah, I just so because only one question related to exponential is there, and people find it difficult to calculate that. Therefore, I explained here, but I can ask the question concept related to that. But if you solve, if you share your solution, if you share your calculations, then I can correct and I can tell you you are making mistake here and do this. So please, whenever you send me any question, share your thought process, share your process of solving that, then I can correct so that you will learn better. Because I am getting some question, I'm not understanding question number 5 in fill in the blanks of this. First, I need to understand what you are understanding, then I can guide you correctly. Any other question, please feel free to ask me. If you don't have any question, then I would like to say have a wonderful evening, have a wonderful week ahead, and have a wonderful time. We will see next Thursday. This is hard for me. So yeah, everything, nothing is easy, nothing is hard. If you practice, it is very easy. So you just, Bridget, you can directly send the email on Canvas.
Okay, sir. I'll just email you if I get stuck.
Yeah, please. I'm always here to answer your question and guide you in the right direction.
I got stuck on the math part some, but
so math part, the calculator and these mini tabs are very simple. But before calculator, like I said, 4 steps that comes from your understanding. Yeah. And then, calculator comes at the last stage to just plug the numbers and get the answer directly. But before that, if it thinking process, thought process is not correct, everyone blames for Minitab. Then no, Minitab is very helpful as compared to Excel. I can tell you.
okay. I'm just gonna go over your PowerPoint slides because it says like step by step how to do it. So.
Yeah. And PowerPoint slides are slides, but I would suggest you to follow the book. Book has some solved examples, some odd problems solved, So follow those, then only you will be perfect. And every, like you ask, every chapter has almost equal weightage in final exam.
Okay. Okay, maybe I'll
Okay.
kind of worried about chapter 7 because that's where I made the most mistakes in the.
But chapter 7 is most beautiful chapter, to be honest, because everything in the world is happening about, based on chapter 7 concept. Where is the median price? What is the standard deviation of housing prices? What is the average price? Let's say you bought a house in this price, in what percentile you are falling? Let's say you are doing a job, average salary of the job is this, and you are getting paid this much. Standard deviation, okay, so you are in 90 percentile of pay. Basically everything is based on chapter 7. That is what we are getting in different TV shows, and people talk about percentile and this and that and that. So if you learn, chapter 7 is most beautiful chapter in entire 2 courses.
Okay. Okay, so I'll spend some more time on chapter 7 because
Yeah.
I got probably 0 out of all of them. Right.
Yeah.
Okay.
Okay.
Okay, thank you so much.
Most welcome. Bye bye. Good night.
Right.